This is thermal physics in 4 minutes.
If you have two objects where the temperature of one object is higher than the other object, thermal energy will transfer from the hotter object to the cold object. This will keep happening until the two objects are at the same temperature or at thermal equilibrium, which means when there's no net flow of energy between two objects. You can measure temperature using the units degrees Celsius or Kelvin, which uses the absolute scale. And 0 Kelvin or minus 273 degrees Celsius is the lowest temperature you can ever have. This is the temperature at which a substance has minimum internal energy. To convert from degrees Celsius to Kelvin, you add 273, and the other way around, you minus 273. In terms of substances, solids have particles which are arranged regularly, but liquids and gases are arranged irregularly. In solids, particles vibrate about fixed positions, whereas in liquids and gases, they move freely in all directions. Solids and liquids have small gaps between the particles, whereas gases have large gaps. Strength of the attractive forces between the particles are largest in solids and weakest in gases. And as you increase the temperature of these particles, solid particles increase in vibration, whereas liquids and gases move around faster. Brownian motion is a term used to describe how gas particles move around. It can be observed using a microscope and a cloud chamber containing smoke and air. When looking through the microscope, you would observe zigzag patterns which show smoke particles moving around and colliding with air particles. This shows us that air particles travel in straight lines, and when they collide against any other particles, they change directions. Internal energy is defined as the sum of random distribution of kinetic and potential energies associated with molecules in a system. The kinetic energy of the molecules are based on the vibrations of the molecules about their fixed positions, and this depends on temperature. Whereas the potential energy is due to the attractive forces which holds the molecules together. This depends on the bonding forces between the molecules. So we can say internal energy, or delta U, is equal to kinetic energy plus potential energy. To increase the internal energy of a system, you can supply heat to the system, which increases its kinetic energy, or supply work to the system, which increases potential energy. Specific heat capacity is defined as the energy required to raise the temperature of 1 kilogram of a substance by 1 Kelvin without changing its state. The equation for this is E equals mc delta T, where E is energy, m is mass, C is specific heat capacity, and delta T is the change in temperature. One value that needs to be memorized is the specific heat capacity for water, which is 4,200 joules per kilogram per Kelvin. To work out the specific heat capacity of a solid, this is the following setup you need. First thing you do is measure the mass of the metal block using a mass balance, then you measure its initial temperature using the thermometer, then you turn on the heater and start the stopwatch. Let the metal block reach a specific temperature and record its final temperature, and then stop the stopwatch at the same time and record the ammeter, voltmeter and stopwatch readings. You can then work out specific heat capacity by rearranging the equation to make C equals E over m delta T. Delta T can be found out by subtracting the initial temperature reading from the final temperature reading, and energy E can be found out by using the equation E equals VIT, using the voltmeter reading, ammeter reading and the stopwatch reading. To find the specific heat capacity of a liquid, you can use a similar setup, but instead of using a metal block, you can use a polystyrene cup with a liquid in it covered with a lid. You can also use a joule meter to find the energy transferred instead of using a voltmeter, ammeter and stopwatch, which saves you a calculation. Specific latent heat can happen at boiling temperature and melting temperature, which means there are two types. The first is specific latent heat of fusion, which is the energy required to change the state of 1 kilogram of a substance from solid to liquid at melting point. So this happens when a substance is melting or freezing. The equation is energy is equal to mass times latent heat of fusion. The second type of latent heat is specific latent heat of vaporization, and this is the energy required to change the state of 1 kilogram of a substance from liquid to gas at boiling point. And the equation for this is energy is equal to mass times latent heat of vaporization. So suppose we had ice at minus 40 degrees and we gave it a constant supply of energy to heat it up. The ice will start at minus 40 degrees and increase in temperature until it reaches melting point at 0 degrees C, and all of this will be happening at solid state. When it reaches melting point, the energy supplied will be used to change the state from solid to liquid rather than increasing its temperature. Therefore, the temperature remains constant at 0 degrees C until it is all turned into liquid. Once it's turned into liquid, the temperature will steadily rise until it reaches boiling point at 100 degrees C. The energy would then be used to convert the state from liquid to gas at boiling temperature, meaning the temperature stays constant, and once it's all turned to gas, the temperature will carry on steadily increasing. When carrying out calculations on the diagonal part of the graph, you'd use E equals mc delta T. However, on the flat part of the graphs, you'd use the latent heat equations. This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.